Open source hardware is awesome. Not just because you get to use people's hard work and innovation for free. I mean, as I always say, you should regularly contribute to and support the projects that you enjoy, but because it also allows for unfettered creativity and collaboration. Maybe that's why I feel like every single day there's an exciting new toolhead or enclosure mod or other upgrade that everyone is just swearing by. That's why in this video, I'm going to try to make some sense of the chaos by hand-picking and explaining the top 23 open source upgrades for your 3D printer. Let's get after it. For those of you just joining us, this is technically the third video in the series, but don't worry, you can watch them in any order. We'll link to the first two, which covered open source 3D printers and multi-material systems, down in the description below. Just please remember to open them in a new tab and come back to this video, because if you leave the video this early, the algorithm is absolutely going to bend me over its knee and spank me, and not in the good way. Let's start off with extruders. As print speeds go up and we get access to more and more exotic filaments, extruder designs have had to keep up. Here are some really cool open source extruder designs that pinch and push plastic without the puffy packaging. Jesus, what is this, Voidstar Lab? The Picolino is an ultra-lightweight, open-source, direct-drive extruder created by Dmitry Romanovich, known online as M-IDEX. Designed to be as small and lightweight as possible, under 150 grams for the full toolhead, it is ideal for high-speed multi-tool setups like IDEX or tool changers where weight matters. Unfortunately, this one is still in development and hasn't been fully published yet, but it does seem to still be under active development, and I felt like it was a cool and innovative enough design to feature it, even if it's not yet out. As with everything I'm going to be featuring in this video, we'll put all the relevant links to learn more in the description. The Galileo 2, or G2E, is Jared CO1's next-gen full redesign of the original Galileo planetary drive extruder built specifically for Voron stealth burner setups. It packs a beefy 9-to-1 custom aluminum or MJF gearbox and a new 9-tooth stepper for 20% more tooth contact, which is always good. It offers smooth, powerful extrusion with minimal wear. The large 16mm drive gear plus idler bearing minimizes filament artifacts, and the planetary drivetrain makes it whisper quiet and high torque compared to the standard Clockwork 2 normally used in the stealth burner. Kits are widely available from LDO, West 3D, and more for around $45 to $55 USD. Up next, the Orbiter is a high-performance, open-source, direct-drive extruder originally designed by Lorincz Robby, with later commercial versions produced by LDO Motors. Now, on version 2.5, it packs a punch with a planetary gearbox, a 7.5-to-1 ratio, which delivers extreme extrusion force and smooth, precise filament feeding, even at high speeds or with slow and soft filaments, while weighing around 130 grams. Unique features include hardened short drive gears, stainless steel exit guides for abrasion resistance, flip gears for better balance, low backlash, and add-on options like a filament sensor with auto load and unload. Costs vary depending on configuration. A DIY kit with printed parts and your own stepper is really budget-friendly, while a full LDO V2.5 motorized unit can go for around $55 to $62 before you get into upgrades. Actually, on that note, let's just take a quick moment to thank this video's sponsor, which is actually LDO Motors. You guys probably already know about LDO. They're known for offering, hands down, the highest quality kits for open source projects like Voron, Positron, the Stealth Changer, Galileo, Orbiter, Milo CNC, and more. But what you might not know is just how much they do behind the scenes for the 3D printing community and open source hardware as a whole. And I'm not just saying that because they were literally the first company to ever give me a chance and send me a review unit for making content when I was just starting out. LDO works closely with the creators of the most exciting open source projects, helping them bring their ideas to market and then supporting their continued development with a percentage of every unit sold. So when you buy one of LDO Motors' high-quality kits or products, you're supporting both open source designers and the future of open source 3D printing as a whole. Plus, LDO works with some of the finest retailers in the industry, such as Matter Hackers, 3D Jake, West 3D, Fabrico, and more. So to check out their full line of products, visit the link in the description or scan the QR code appearing on the screen right now. And thanks again to LDO for their continued support, not just of me and many other content creators, but of this entire hobby. I mean, seriously, how many other companies would offer to sponsor a video that gives equal screen time to their competitors' products just so that you, the audience, can choose whatever's best for you? Pretty cool of them. All right, let's get back to the video with more extruders. The Sherpa Mini is an open source dual gear direct drive extruder developed by Apex Engineering and Anlin with refinement and multiple releases to improve torque, silence, and build ease. It uses a dual gear hob design to deliver serious extrusion force quietly and smoothly. And it weighs in at around 136 grams in the mini version. You can self-source or buy ready-made kits starting at around $60 for the CNC machined versions, including the motor, and you can do that from Physek or Fabrico. Hey, wanna get weird? Then check out the Rainbow Dragon, a dual filament extruder for the Voron 0.2 and printers for ants, but you can put it on anything really. It's based on the Phaetus Tai Chi dual filament hot end and uses 2 stepper motors to extrude 2 different filaments through 1 nozzle. That's pretty cool. Actually, my first printer was a Bowden 2-color mixing nozzle, but I've never seen anyone try to extrude 2 filaments right in the tool head just like this. You're looking at around $100 between the hot end, some stepper motors, 2 sets of BMG gears, and so on. But be warned, this is a work in progress, and it will take a lot of tinkering and tweaking, both in hardware and software, to get it working reliably. You'll also need to switch your tool head to a dragon burner, which leads us to our next section, tool heads. After all, if you want to upgrade more than just your extrusion, say you want lighter weight or better cooling, well, in that case, you will need to check out these incredible open source toolhead projects, starting with the one I just mentioned, the dragon burner. Now, we all know the Voron stealth burner. It's literally right behind me. It's a sleek, integrated design that seems to have become the default for most Voron builds. But it's also a chonky boy, and it offers lackluster cooling at best. Enter the Dragon Burner, an open source, high-flow printhead originally developed by the Voron community and led by contributors like Chirpy2605. Refined over many iterations, it is designed for speed, featuring dual 4010 part cooling blowers and a 3010 hot end fan, plus optimized ducts based on extensive CFD testing. Like the Stealth Burner, the Dragon Burner offers broad compatibility with all the major hot ends and a full ecosystem of upgrades. But what really stands out is its modular design. Printed cowls, integrated LED mounts, probe support, and swappable extruder mounts for things like the Sherpa Mini, the Orbiter, etc. Like this entire list, it is fully open source with STL, BOM, config files, and so on GitHub and Printables. You can print your own, or you can pick up some CNC machined aluminum versions in the description. Now, if you like the idea of the Dragon Burner, but you want to go even faster, then you will want to check out the Rapid Burner, also by the homie Chirpy2605. It features almost all the same specs and components as its smaller cousin, but it's stretched to fit Phaetus's ultra high flow hot ends. Up next, check out the Yavoth Toolhead by, you guessed it, Chirpy2605. It's designed around high flow and ultra high flow hot ends while being more compact and lightweight than the Rapid Burner, which makes it perfect for tool changers or smaller setups. All right, I think that's enough publicity for Chirpy and his amazing projects. Let's change gears, and I swear, no pun intended, and talk about another prolific toolhead designer, or rather a pair of designers, which is Nadir and Christian of CN3D. These guys have earned a name for themselves designing upgrades for a wide range of printers, namely Sovol machines, but they've also done some really cool open source spin-offs from the Voron project, such as the Spartacus toolhead, which I'm actually using in my own 7-tool changer, if I ever finish it. Based on the Voron Mini Stealth Burner, Spartacus offers a number of improvements to both performance and polish. It offers integrated NeoPixel LEDs, smart cooling ducts, integrated toolhead board cooling, a wide range of supported extruders including Bondtech BMG, LGX, and even the LDO Orbiter. Best of all, it relies heavily on printed and off-the-shelf parts, making it really affordable to build. Not to mention, its smaller footprint means that you can fit more of them into your tool changer build, because who knows when we're actually going to get our hands on the Bondtech Index. Links in the description. Up next, let's look at one of CN3D's more unique designs, the Xenomorph. Originally designed for the Sovol SVO8, the Xenomorph has a lot of unique and clever elements. From its magnetic pogo pin connectors for easy LED and fan swaps, customizable fan ducting for dual-part cooling 4010s, and compatibility with the Orbiter extruder. It even has filament sensors and a filament cutter, making it MMU friendly and future-proof. But let's be real. The actual main reason to choose the Xenomorph is the sleek design that covers all of the chaos, no matter what toolhead board you choose to go with. STLs and BOM are linked in the description. With some of CN3D's designs now covered, let's switch to yet another very prolific designer, Armchair Heavy Industries, and their Zoll toolhead. Evolved from their popular Mantis, the Zoll emphasizes modularity, serviceability, and airflow. It uses dual 4010 blowers and a 2510 hot end fan, and can reach 12K RPMs for peak cooling performance. All that, and it weighs in at just 260 grams with a Sherpa mini extruder. On the GitHub page, they call it ugly, but personally, I think it looks absolutely sick, especially the CPAP version. But if praying mantises aren't your thing, then maybe you'd prefer the AntHead, the featherweight toolhead from the Printers for Ants crew. But don't worry, it can be fitted to bigger printers as well. Like many of the toolheads on this list, it makes use of dual 4010 blowers and a 2510 hot end fan, but this one makes use of the Galileo 2 rather than the Sherpa Mini. In many ways, I guess it kind of rivals the Dragon Burner, but in my opinion, it looks a lot nicer. No offense to you Dragon Burner enthusiasts out there. Up next, let's have a look at the ArcheType, Armchair Engineering's ultimate modular toolhead ecosystem. It's built for complete customization and caters to those looking to push the limits of FDM. It supports a wide range of duck options like the Atrocity, Blackbird, Breakneck, Mjolnir, and Zephyr. It also has multiple hot ends from the Rapido and the Dragon Ultra High Flow, the VZ-Bot Goliath. It even supports different extruder styles like the Sherpa Micro, the Sherpa Mini, the Orbiter, the VZ Hextrudort, and much, much more. I've actually even seen some crazy CPAP setups based on the ArcheType, which were pretty cool. Now remember how earlier I said that most of these designs seem to use 4010 blower fans? Well, apparently, I'm not the only one who noticed, because Armchair Heavy Industries actually named this one the A4T, or another 4010 toolhead. Those 4010s are hooked up to focus ducts for excellent cooling and compact airflow efficiency, and you get built-in NeoPixels to light up the print zone. There are modular board and extruder mounts to support lots of extruders, including the Sherpa Mini, the Galileo 2, the Orbiter, the LGX, and even more. And unlike a lot of these toolheads, the A4T also has future-proofing community mods like filament cutters and even shaker arms. A full DIY build should set you back $60 to $80, depending on your choices. Now, if all those options sound a little bit overwhelming and you just want a well-designed, fully integrated toolhead and extruder that are guaranteed and designed to work well together, look no further than the relatively new Jabberwocky. Designed for high-performance, multi-material setups, it emphasizes reliable filament swaps with an integrated cutter. But that's not all. While this is an open source design, there are kits available with an integrated Fadis conch hot end capable of 35 cubic millimeters per second flow. There's a Bondtech compound drive gear driven by an LDO NEMA 14 stepper, and it includes an LDO Nighthawk 36 USB toolhead board. And it's all designed to work together. Plus, it has lots of other features like status LEDs, high static pressure fans, cable strain relief, and even more. This one is available assembled or non-assembled. It costs about $150 all in, and they should see batch 2 delivered sometime around July 2025. Now, if you've made it this far in the video and you still haven't found that perfect toolhead that suits your fancy, not to worry. You can always build your own HeroMe Gen 7 by MediaMan 3D. The HeroMe isn't so much a toolhead as it is a complete platform for total customization and compatibility. You can kind of think of it like Lego for 3D printer toolheads. It has a standard base with swappable mounts for hot ends, extruders, fans, probes, LEDs, accelerometers, and even cable guides. and it's all maintainable and upgradable over time. According to users, its part cooling is top tier, outperforming many stock setups while staying lightweight. And unlike many of the toolheads we've covered before, which are designed for Vorons or at the very least printers that use 2020 extrusions, the HeroMe supports 115 plus printers, 47 hot ends, 37 extruders, and dozens of other accessories, with more compatibility added every release. Honestly, my hat is off to Media Man 3D. He may call this the HeroMe, and he may have a Superman-style logo, but this is a truly Herculean effort that he's made for the good of the community, so links in the description. All right, so you're printing faster and cooling better. Now let's upgrade that enclosure, if you have one, so that you can print safer, hotter, or more conveniently, starting with these printable snap latches. Okay, it might be an exaggeration to call these an open source project, but I just had to share them because I got so annoyed and frustrated with my old magnetic latches, and since switching to these, honestly, life has been so much more convenient. Basically, these latches allow you to remove the panels of your Voron in seconds, but unlike the magnetic latches that many people, including myself, use, they don't require that you get the panel in the right orientation, nor do they fall off when you try to print gyroid infill. 2 thumbs up. Up next, we have the Nevermore, a family of open source activated carbon filter modules designed to scrub VOC fumes inside enclosed printers. It can get a little bit confusing because there's the V4, V5 Duo, V6 Micro, and now even XL versions to fit everything from a Voron 0 to a 2.4 and even your custom builds, but each model basically recirculates filtered air back into the chamber, helping retain heat, but they'll also strip fumes even when the doors are open. Basically, pick your size depending on your space and fan power, but whatever you choose, you get cleaner air without having to mess with the chamber temperature. Just please remember to pick up acid-free carbon or you'll regret it. Up next, let's talk about a much more controversial and, honestly, dangerous upgrade, and that's the iHeater. As the name suggests, the iHeater is a compact and affordable solution for 3D printers without an active heated chamber or with limited connectivity to the main board. It is especially useful for models with proprietary boards where there are no available ports for a fan, a heater, or a thermistor. iHeater solves this problem in a simple and universal way. It can operate independently with its own firmware as a standalone device under Clipper control or even connected to the printer via USB. Now it all looks and sounds very good, but it doesn't come without risks. Chamber heaters, especially ones that pull 100 watts from 220 volt mains power, are extremely dangerous. Not only can they cause electrocution and death, but they can also burn your house down. This is not a joke, which is why the Voron team explicitly bans any discussion of chamber heaters. With that said, Ruslan does seem to know what he's doing, and he has added safety features like a thermal fuse to the board. I'm actually going to be testing and experimenting with the iHeater and giving him some feedback in the coming weeks with the help of a certified electrician friend. But please, if you are not well versed in how to safely work with mains voltage, do not attempt this one at home. All right, now I know we did a full video on multicolor systems, which you should definitely watch after this one if you haven't already. But one thing that we didn't cover in that video was just all of the little add-ons and upgrades and accessories that the community has come up with to make those systems function more smoothly. So let's take a look at those, starting with the Filametrix or Filametrix filament cutter by Sorted01. In that previous video on open source MMUs, I mentioned that most of them rely on you adding a filament cutter to remove those wispy, soft filament tips. But which one should you use? Well, if you're running the Stealth Burner, you'll want to check out either the Filametrix or the Filametrix filament cutters. I know, it's super confusing, but one is basically an adaptation and cleanup of the other. Either way, it adds a kinematic actuated cutting blade right to the toolhead for clean, reliable filament changes, and it's a cinch to build. But what about purging? For that, you'll want to check out the Blobifier by Dendrauen, a clever purge collector that replaces bulky purge blocks. Essentially, it automatically extrudes neat little blobs into a bucket and even scrubs your nozzle before resuming the print. Plus, by extruding blobs instead of purge blocks, you save both time and material. It mounts rear left on a Voron 2.4 or a Soval SV08 panel. It uses a servo to shake the blobs downward, and it auto-pauses when the bucket is full, so no messy cleanup. There are kits available that include a brass or silicone brush, plus a PCB, micro switch, and a bucket, all for around $22 to $30. Also, do make sure to check out my podcast interview with Dendrauen if you're curious. So, we've dealt with cutting, we've dealt with purging. What about respooling and preventing tangles? Well, unless you're running something like the Box Turtle, you will want to check out the Filamentalist, a slick, passive spool rewinder made for a wide range of Voron MMU setups. Believe it or not, it requires no electronics, no motors, just smart mechanical design, a spring-loaded clutch, and O-ring rollers driven by the filament's axial push to reel in slack during unloads, minimizing buffer friction and saving space. That's confusing as hell, so here, just watch this thing in action. Full BOM, STLs, and installation guides are on GitHub, with kits hitting AliExpress for around $8 per spool, and user mods for things like RepRack rolling out as well. All right, we've made it to the deep end, the other upgrades that just didn't fit in any other category, but which I'm pretty sure you guys will notice if I admit. So before we wrap, let's talk about Voron TAP. Voron TAP is Voron's official open source Z probe system that ditches the old inductive probe or user mods like Clicky in favor of using the entire hot end as the probe. It works by mounting the tool head on a kinematically suspended frame with a Hall effect sensor. So when the nozzle touches the bed, TAP knows about it. It's stupid accurate, super repeatable, and totally eliminates probe offsets. And since it's a mechanical trigger, it works on any surface, even glass or very dirty beds. Personally, I don't use TAP because I feel like adding a metal rail and carriage will make my already massive tool head even heavier, but this is an open source alternative to the E3D-PZ probe that I personally do use, so there you go. And finally, we have the Roadrunner filament motion sensor. As you might know, I print a lot of home recycled filament, and I also have quite a few large printers. So as I've ranted in the past, I'm of the opinion that in 2025, a filament runout sensor just isn't enough. We need filament motion sensors that trigger when the filament is clogged or jammed. Now in the past, sensors like these were wildly expensive. Fortunately, the commercial ones have come down in price, but if you don't want to deal with ordering or you want to save a few bucks, you can actually create your own. And you can do it using the Roadrunner filament motion sensor. With just $12 worth of parts, including a magnetic rotary encoder, a status LED, an IR switch, and a PCB, this little doodad can track sub-millimeter filament movement and feed it back to your printer via UART or I2C. Nice. So there you have it, my hand-picked list of the 25 or so most exciting open source toolheads, extruders, and upgrades for your 3D printer. But as always, I am sure that I missed a lot of really great projects, and I know that you guys are gonna let me know all about it in the comments below. So who knows, maybe I'll do another video in the series. Subscribe if you guys like this one. That's all for this week, but I'll see all of you on the next layer.